Welcome back. This is Professor Edge, and today's lesson is on section 1.1, Introduction to Graphing. Let's start off with reviewing the Cartesian plane, or the XY axis. So we can the horizontal axis is the x-axis, the vertical is the y-axis. The point in the middle where they meet, we call that the origin. And if you recall, the x and y axis splits the plane into 4 quadrants. Quadrant 1, and then you go counterclockwise from there. So this is quadrant 2. So we kind of basically go counterclockwise. Quadrant 2, quadrant 3, and it's pretty normal that we use Roman numerals to mark the quadrants. Okay, each point x, y in the plane is described by an ordered pair. So an ordered pair describes the location on the plane. And then the first coordinate, the x-coordinate, so the x-coordinate indicates the point's horizontal position with respect to the origin. So it tells you how much, it tells you the side-to-side motion counting from the origin. Okay, and then the y-coordinate is the same thing, but gives you the vertical position. Okay, so let's practice graphing points, and remember, so the origin is where everything's counting from, so the origin is right there where the x and y intersect. So starting from the origin, we label 1, 2, 3, 4 going to the right. Going to the left is negative, negative 1, negative 2, 3, negative 4. Going up is positive, 1, 2, 3, 4, and then going down is negative 1, negative 2, negative 3, negative 4, negative 5. So if I wanted to plot the point 3, 2, you're going to start at the origin, you're going to move left 3, and then to the right, then up 2. So the x-coordinate tells me my horizontal position, tells me where to go on the x-axis. And then the second coordinate tells me it's going to be up 2, so we'll go vertical 2. So another way you can think of it, right? So that's the vertical position's 2, the horizontal position's 3. So it's 3, 2. That's point B. Oh, I'm sorry, that's point A. And B is negative 3, so we go left 3. And then y-coordinate's 1, so we go up 1. And let's see, C is 2, negative 5, so we're going to go right 2, down 5. 1, 2, 3, 4, 5. And then D is 0, 3, so you're going to go right 0 and then up 3. So it's right there. And then E, negative 3, negative 4, so I'm going to go left 3, down 4. Okay? So as simple as that. Alright, let's look at this example. It says use substitution to determine whether the given ordered pairs are solutions to the equation. So I want to remind you that solutions means, again, solutions to an equation are replacement values of the variable that make the equation true. So basically we're asking if we plug in negative 1, negative 9 in for x, y, because remember it's an ordered pair, is it a true statement? So we're going to try 7, x minus 2. We're going to plug in negative 1 for x, negative 9 for y. So that's going to give us negative 9 for y, negative 1 for x. Then we work, and we're asking that question, is that true, yes or no? So we get negative 9 equals negative 7 minus 2. And that's true. So yes. Okay, now let's try it for 0, 2. So we're going to put in 2 for the y, 0 for the x, and you can see that 2 equals negative 2, that's false. So yes, negative 1, negative 9, so it's yes, negative 1, negative 9 is a solution, and this one is no. 0, 2 is not a solution. Okay, so that's the solution. Now if you recall, a graph is just a picture of the solution set. Okay, so if I asked you, instead of saying solve y equals 3x plus 5, the problem is there's an infinite number of solutions and you can't write them all out. And remember, to solve an equation means you find all the solutions, all the things that make it true. So that would be impossible to write it down, so what we do is we draw a picture of it, we graph it. Okay, and you recall this is a linear equation. You should know 3 ways to graph a linear equation. Your first technique is you can make an x and y table. And you just pick numbers for x, like 0, 1, negative 2. Plug them into the equation. So if you plug in 0 for x, 3 times 0 is 0 plus 5 is 5. So 0, 5 is the first point. If you do y equals 3 times 1 plus 5, that's 8. 3 plus 5, which is 8. And then if you plug in negative 2 for x, so you get negative 6 plus 5, negative 1. And then you plot these 3 points, 0, 5, 1, 8, negative 2, 1, on a graph, and then draw the line through it. Okay, so we're going to start with 0, 5, and if you recall, that's called the y-intercept. We're across the y-axis. 1, 8, and then negative 2, negative 1. So I plot those 3 points, put a ruler down, which you can't see, and then I magically draw the line through them. And then that's the line y equals 3x plus 5. Now again, I want to emphasize this. Every point on this line is a solution to the equation y equals 3x plus 5. Every point that's not on the line is not a solution. So you can look at this real quickly and see what works, what doesn't work. All right? Okay, so x-intercepts they're the points where the graph, the pointer points, depending, you can have more than one x-intercept. It's the pointer points where the graph crosses the x-axis. Okay? So it looks something like it's some number 0. Now again, to be on the x-axis, right here, we know for sure that the y-coordinate has to be 0. That's how you're going to be on the x-axis. So, knowing that, to find the x-intercept, you're going to let y equal 0, you're going to substitute that into the equation, and then solve it for x. And similarly, the y-intercept is the point where the graph crosses the y-axis. It's going to look like 0, comma, some number, b. And again, it's the same idea, right? To be on the y-axis, I know for sure that the x-coordinate has to be 0. And I just have to figure out what the y-coordinate is to know where it is on the y-axis. Okay? So to find it, we do the same thing, except now we're going to let x equals 0 and solve for y. Okay, so let's find the intercepts of this equation, 2x minus 4y equals 8, and then graph the line. So this is the second technique we learned for graphing lines. Is we know that two points determine a line. So if we found the x-intercept and then we found the y-intercept, 2 points determine exactly one line. I can draw the line through it and then I'm done. Okay? So we need to figure out what the x-intercept is and what the y-intercept is. So we have to figure that out. Alright, so to find the x-intercept, this is what I do, x-intercept. Remember, we know it's some number 0, so you're going to let y equal 0. So this is kind of what I repeat to myself because I always get confused with these. X-intercept, you're looking for x, so you're going to let y equal 0. X-intercept, you're looking for x, let y equal 0. So we're going to put 0 in for y. And then this part is 0 and it just goes away, so I just kind of ignore it and then I just see 2x equals 8. Alright, 0, so it just goes away, and then you divide both sides by 2, so x equals 4. So the point is going to be 4, 0. Now for the y-intercept, do the same thing, except switch it around. We know it's 0 some number for y. So we're going to, again, y-intercept, I'm looking for y, so we're going to let x equals 0. Y-intercept, you're looking for y. And we're going to solve for y. So we put in 0 for the x. And again, that term is going to go away, so now this goes away, so we got negative 4y equals 8 divided by negative 4. And typically when I do this, I don't even show any work because it's super easy. If you could see me in class, what I would do is right here where I'm scribbling this, I would just put my finger over the 2x and hide it and just say, okay, negative 4 times what equals 8? And everyone says negative 2. And you get it real quick and easy without, you don't have to show work on that. Okay, so there's my two intercepts. My x-intercept's 4, 0. So I go to 4, 0, put a point. And then my y-intercept 0, 2. 0, negative 2. So I put a point at 0, negative 2. And then get my ruler and draw my line through it. So that's 2x minus 4y equals 8. Okay, so that's a very nice technique, especially when the coefficients of x and y divide evenly into the constant. Makes a really great way to graph. Alright, on to the next thing, distance formula. Next page. Okay, so before we do the distance formula, I want to talk about Pythagorean Theorem. So, most people learn this early on in their math career, and if we have a right triangle, and I call that A, B, and C, and I ask people, okay, what's Pythagorean Theorem? And most people, without hesitating, will say A squared plus B squared equals C squared. It's pretty famous theorem. And so what I want to show you is that the distance formula is just the Pythagorean Theorem in disguise. So if I put this triangle on an XY axis, okay, so I want you to find C, the distance from the point 2, 1 to 6, 4. And notice I drew the triangle to show you that the distance formula really is Pythagorean theorem. So let's forget about calling it distance. If I drew this picture of this triangle, can you tell me the length of this side? And you can easily see that, hey, this point here where the right angle is 6, 1. So the vertical position is 1, and the distance from 1 to 4, two ways you can do it. You can count it, 1, 2, 3, or you can say, well, the y-coordinate 4 minus 1, that's 3. And then when I want to do the horizontal for A here, so that's my B, that's my A. Now for A, it's this distance from 2 to 6. So again, I can count 1, 2, 3, 4. Or if I want to be fancy, I can do the x-coordinate here is 6, the x-coordinate here is 2, and I subtract them, that gets me the distance. You know, a straight line on a horizontal line. You just subtract the x-coordinates. So that's 4. So now, if I ask you to find C, you can use Pythagorean theorem. I'm going to flip the formula around. C squared equals A squared plus B squared. So we know A is 4 squared, B is 3, square it. So you get 16 plus 9, which is 25. And then C squared is 25, so square root both sides, and C is 5. And you ignore the negative 1 because this is a geometry problem. So your distance is 5. All right, so you can see to find the distance between 2 points, we can just use Pythagorean theorem. But of course, we're going to generalize this. We're going to call point, the 2, 1, we're going to call it x sub 1, y sub 1. Point 2 would be x sub 2, y sub 2. And again, define the A, define A, here let me redraw this. So we got x sub 1, y sub 1, x sub 2, y sub 2. So this is x sub 2 if we're on xy axis. This y coordinate is y sub 2. This x coordinate is x sub 1. And this y coordinate is y sub 1. So the distance for A is going to be the difference in the x coordinates. So it's x sub 2 minus x sub 1. B is going to be the difference in the y coordinates. So when I do the Pythagorean theorem, and we're going to call distance, this is the distance formula. So the distance between 2 points so the subscripts are just distinguishing characteristics to say, hey, x sub 1, y sub 1 is 0.1. So that's the x coordinate for 0.1, the y coordinate for 0.1. X sub 2, y sub 2 is given by okay, so I'm going to leave it blank. Let's go back up here and see if we can figure out the formula. So let's mimic this c squared, we'll call that b squared. Then a squared is a is x sub 2 minus x sub 1. B is y sub 2 minus y sub 1. Okay. So that's a squared plus b squared equals c squared, but I'm calling it b now. And then I'm going to square root both sides, And I'm going to get the square root of that expression. X sub 2 minus x sub 1. Y sub 2 minus y sub 1 squared. Okay, so it's given by the formula, and that's our distance formula, which again is just the Pythagorean theorem. Just maybe not haven't thought of it that way before. So there we go. Plus, so it's a squared plus b squared equals c squared, and then we square root both sides. So that's where the square root comes from. Alright, so that's the distance formula. You've got to have that memorized or be able to recreate it. Okay, and the next formula we need to know is the midpoint formula. And my claims, you know this one already too, and all it is, it's the average. If I wanted to find the average between the average, the middle, between, say, 2 and 6, you would just add them. 2 plus 6 is 8, and divide it by 2 and get 4. So I want you to think average. Okay, so the midpoint formula. So the midpoint between x sub 1, y sub 1, and x sub 2, y sub 2 is given by, okay, so capital M for your midpoint. You're going to add the x coordinates, divide by 2. That gives you your midway between the x coordinates. So for the example we did up there, the 2, 1, 6, 4, you do 2 plus 6 is 8, divided by 2 is 4, so the x coordinate would be 4. And then you're going to add the y coordinates and divide by 2. So the one we did up there was the y coordinates are 1 and 4, so 1 plus 4 is 5, divided by 2. It's 5 halves, or 2.5. So the midpoint would be 4, 2.5, which would be right about there. Alright, so easy enough. Okay, let's do an example. Find the distance in the midpoint between the 2 points, 4, -9, and -12, -3. So the distance, remember, you're going to subtract the x coordinates, square it, subtract the y coordinates, square it. That's your a squared plus b squared equals c squared. Pythagorean theorem. Okay, so let's plug in the numbers. So I'm going to subtract the x coordinates. -12 minus 4. Subtract the y coordinates. -3 minus -9 squared. So that would be -16 squared. And this will be 6 squared. So -3 plus 9, so it'll be -6 or +6 squared, and that will give us, see, 256 plus 36, which will get us 80. Don't have my calculator, hang on. Okay, so that's square root of 292, and 292 is 2 times 2 times 73, so we can factor 2 out, so it's 2 square root of 73. Or, you know, you can put it in your calculator and say it's about 17.088, depending on what you're doing. Okay, but this is the exact answer for distance, 2 square root of 73. And then the midpoint, and that's really easy. We're just going to add the x coordinates. Remember, think average. So you add the coordinates and divide by 2. So we're going to get 4 plus -12 divided by 2, and -9 minus 3 divided by 2, which will get us Negative 8 divided by 2 is negative 4. And negative 11 divided by 2 let's see, did I do this? Oh wait, but negative 11, it's negative 12 divided by 2. I knew something was funny. Okay, that'd be negative 6. So our point is 4, negative 6 is the midpoint. And then our last thing in this section is the equation of a circle. And it turns out that, you know, the definition from geometry of circles, if you have a given point, it's the set of all points that are equidistant from your given point. We call that the center. And then if this distance, we'll call it r for the radius. We get all these points that are equidistant. I'm just freehanding this, so it's not a very good circle, but there, that's the idea. So all these points that are, say, 3 units away will create the circle. And it turns out that we just use the distance formula for this. So again, it's Pythagorean Theorem in disguise. So we're going to make that the variable xy. hk is the specific point for the center. So if I use the distance formula for this, r is the distance. So let's flip the formula around again. A squared would be, so remember we're going to subtract the x coordinates. So it's x minus h squared. B squared, we're going to subtract the y coordinates. It's a k. Y minus k squared equals c squared, which is my r. Okay? So it's pretty simple, the equation of the circle. If you know Pythagorean Theorem, then you should know the distance formula, and you should know the equation of the circle. They're all the same thing. So you memorize that. This is center, where center equals hk, and the radius equals r. Okay, so let's try to find an equation of a circle satisfying the given conditions. So let's say we have center is 4, 5, and the diameter is equal to 8.2. Now if you recall, the radius, or 2 times the radius equals the diameter divided by 2. Or 2 or twice the radius equals the diameter. Okay? So to get the radius, we need to take radius equals diameter divided by 2. So it's 8.2 divided by 2, which is 4.1. Alright, now we're ready to go. So once you know the radius in the center, you just plug it in. X minus h. So, and notice it's minus h. See, this is minus h and this is h. So the signs are opposites. So x minus h plus y minus k. So x minus h squared. So x minus 4 squared. Y minus k, which is 5 squared, equals 4.1 squared. And then you just punch that in your calculator. Just simplify it. So 4.1 times 4.1 is 16.81. Pretty straightforward. Alright, let's try another one. Okay, this one looks pretty challenging. We want to find the circle given that the points negative 9, 4, negative 2, 5, negative 8, negative 3, and negative 1, 2 are vertices of an inscribed square. So let's see. And I'm just going to do a rough sketch of these points. I don't really care. So the idea is, you know, we got this circle, and we're saying that we got this square inside. And again, I'm not doing this to scale, but Or maybe I should. Negative 9, 4. Negative 9, 4. Be roughly there. Negative 2, 5. There. Negative 8, negative 3. Right about there. And negative 1, negative 2, right about there. So again, it's not the scale, I just want to get an idea. So we got negative 9, 4, negative 2, 5, negative 8, negative 3, negative 1, 2. And the idea, if that's on an inscribed circle, that's the diameter. Because if you got your circle going around it, those points are on the circle. So you're going to get this diameter. So find the midpoint. Okay, so the midpoint between negative 9, 4, and what was this point? Negative 1, negative 2 is going to be your center. So you're going to add them. Negative 9 plus negative 1 divided by 2. And then add the y coordinates. 4 plus negative 2 divided by 2. And we get negative 5, negative, or 1. So negative 5, 1, right about there, is my center. Okay, that's your center. Now the next thing we got to do is figure out the distance, the radius. So remember, the radius is the distance from the center to any point on the circle. So you can also just use the formula, the distance, the circle formula. So x minus h squared, y minus k squared equals r squared. Because remember, this is really the distance formula. So whether I use the distance formula or I use this, so I can put in any point, say negative 9, 4. Negative 9 is my x, 4 is my y, and remember my center is negative 5, 1. So minus a negative 5, and my k is 1. And that's r squared. So I get negative 9 plus 5, which is negative 4, 3, so 16 plus 9 is 25. So r is 5. But I don't really care that r is 5, because to do the formula I just need r squared, which is 25. So that's an extra step. I don't need to do it. So so our answer is going to be x minus h. H is negative 5, so it becomes plus 5. Plus y minus k, y minus 1 squared equals 25. That's r squared. And there you go. So that was kind of challenging. Okay, so the graph circle is pretty easy. All you have to do is identify the center. So again, the center would be hk, so it's the opposite of this number. So it's 1. That's for your x. X is with, so I always say this, x is with x, y is with y. The opposite of negative 5 is 5. So that's my center. And the radius squared is the 36, so the radius is 6. Because you square root. Alright, let me draw the graph. Okay, so the center is 1, 5, so 1, 5 right here. And then if you have a protractor, you set it, compass, you set the distance for 6 units. If you don't have one, you kind of freehand it. 1, 2, 3, 4, 5. So I do 6 up, 6 to the left. So 1, 2, 3, 4, 5, 6. 6 to the right. 6 down. And then you kind of make your best attempt at a circle, but if you happen to have a protractor, a compass, there's a difference. You set your distance for 6 units. And then draw it in. Okay, I don't know what happened with my compass isn't working very well. So anyway, that's the way you do it. So if you're doing it on the computer software program, it's pretty easy. You just set the center, and then you drag out the circle until you get the radius to be 6 units. All right, so as simple as that. Okay, so that concludes the lesson for 1.1. Go to My Math Lab, complete your exercises there, and I will see you next time.